Good afternoon. Thank you for joining me in the very last lesson. So I'm Dr. Wiggins. I'm from the University of Pretoria. And this quote, I like this quote. So it goes, without mathematics, there's nothing you can do. Everything around you is mathematics. Everything around you is numbers. And I'm sure I don't have to tell you guys how cool mathematics is. So the first problem that I want to do tonight is this problem. It is a nice geometry question and it goes as follows. You have two circles. The one circle has center O and you have another circle that passes through O and intersect the other circle at points A and B. And we also have that the circle on the left has diameter CD, so it passes through the center of the circle. And when you extend the diameter, it intersects the other circle at point P apart from point O. So point P and O are different points. And so this multiple choice question, which was in the South African Teams Maths competition from last year, has 4 options and then E is none of these. Alright, when I set papers for my first year students and also my second year students, I like putting multiple choice questions where I give 4 answers and then I put an option E, none of these, because sometimes when you do a multiple choice question, you get something that's not listed there, then you can go for E. Alright, so and sometimes it does happen that the answer is E. Alright, now the trick in solving this question is as follows. What you do is, being inspired by all of those options, what you do is you construct point A dash on the circle on the right. So when you get a geometry question, you got to draw it. And the way to solve this question is you draw point A dash on the circle on the right so that the angle of A dash BC and BBC is the same. Can I get a smiley face from everybody that you guys agree? This is the diagram of the problem, and the starting point is to construct point A dash on the second circle. I have 3 smiley faces. Can I get 2 more smiley faces? Thank you, Lindy. Thank you, Chatterjee. Can I get another smiley face? There's lots of people here. Thank you, Talar. Thank you, Alex. All right. So we end up getting this. All right. And now, especially the matrix, what can you conclude from this diagram? So looking at this, what can you conclude? All right. So focus on the 2 pink angles that are equal now. Focus on the 2 pink angles that are equal now. You can speak the observation that I'm looking for, or you can type it in the chat. So knowing that those 2 pink angles are equal, what can we deduce? Anybody? If you're matric, you should have seen this beautiful result about circles. Goodness, have I stumped all of you guys? Nobody? Anybody? So, if you have a circle and you look at that chord, what can you tell me about these 2 angles that I label over here? Anybody? So, yep, quite right. Chatterjee and Lindy, quite right. So angles subtended by the same chord have the same size. So the chord OA dash gives you this angle and the chord OB gives you this angle. So what we can conclude is, because those angles are equal, we can conclude that OA dash has to equal to OB. Well done, Edward. Alright, so because the 2 pink angles are the same, we know that OA dash and OB is the same. This is a result that's in your geometry textbook. So if you're matric, I'm sure it's lurking somewhere in your textbook. Alrighty. Now remember, O is a circle O is the center of the circle on the left. So we know that I'm not adding reasons. You will add reasons in when you rewrite this question later today. So because O is the center of the circle on the left, we know that OA is equal to OB. So therefore we get that OA is equal to OB is equal to OA dash. And so it's quite clear, if you now look at this, we can see A is on both circles. Can I get a smiley face that you guys see this? A is on both circles and A dash is on both circles. Alright, so can I get 2 more smiley faces? Can I get another smiley face? Thank you, everybody. Alright, and so now looking at all of this, alright, A is on both circles and A dash is on both circles. What must be true? So thus, looking at all of this thinking and analysis, what is the golden conclusion now? Look at the picture. Look at what we've written so far. Yes, the first gold star for the evening goes to Miss Chatterjee, is that A and A dash is the same point. So A and A dash is the same point. Alright? So A and A dash is the same point. And so therefore, what is the answer to this multiple choice question? So with this analysis, we see that A and A dash is the same point. And so, let me know in the chat, is the answer A, is the answer B, is the answer C, is the answer D, or is the answer E? What do you guys think? Yes. Alright. The girls is ruling the night so far. The answer is C. Alright. So because A is equal to A dash, it means that the angle APC and BPC is the same. Are there any questions or comments before we move on to the next question? So this question was in the team's paper from last year. Alrighty, it looks very quiet. Alright, so I'm sure that you guys are all happy. I don't hear any questions. So let's move to the second problem for the night. Alright, this is the problem. So how many pair of real numbers? So x could be positive, x could be negative, or x could be 0. Y could be positive, y could be negative, or y could be 0. Are they exactly satisfying this equation? Alright, so can you guys let me know in the chat, what do you think of this problem? Is it easy? Is it hard? Or is it bizarre? Give me some adjectives. What do you guys think of this question? Any takers? What do you guys think? I'm looking for 3 adjectives. Lindy is saying interesting. Richard is saying odd. Can I get one more adjective? So this is a nice thing about Olympiad problems. Sometimes you get unseen problems, but you need to be clever and cunning and creative to solve them. Alright, so thank you, Edward. Interesting and intriguing. Alright, so looking at this question, one thing that you can think of is the following. We know that root a minus root b squared is greater or equal to what value? So root a minus root b squared. So if a is greater or equal to 0 and b is greater or equal to 0, if you square something, what's the smallest value that a square can be? Thank you, Lindy, is 0. Alright, let's call this theorem 1. So if you rewrite this, you get a minus twice root ab plus b is greater or equal to 0, and you get a plus b is greater or equal to twice root ab. Another way is, this is also called the AMGM. So there are many ways you can derive this. Alright. Now, the second observation is the following. If you look at the exponent, you get x squared here, and if you look at that exponent, you get x there. Alright? Who can tell me how would you find the minimum of this parabola? You can unmute. If you have a working microphone, you can unmute. Or you can tell me in the chat, how would you find the minimum of this parabola y is equal to x squared plus x? I have one idea in the chat. Can I get another idea in the chat? I hope you have pen and paper. I hope you're also trying this question. Edward, how do you get the local minimum? Edward, how do you get the local minimum? I want a plan. So yes, I want the local minimum, but I want to know, how do you get the local minimum? How would you tell your classmates? All right. So yeah, you can use calculus, but what I'm going to do is I'm going to take Chatterjee's approach. I'm going to complete the square. So if I complete the square, what do I have to add and subtract? Who can tell me, if I complete the square, what do I add and what do I subtract? This is something that you would have seen in grade 10. So, yep. Gold stars to everybody that's saying a quarter. So we can see this becomes x plus a half squared minus a quarter. So you can see it's greater or equal to minus a quarter. And we can see the minimum occurs when x is equal to minus a half, because then the bracket is 0. Can I get smiley faces that you guys see? That x squared plus x, the smallest that x squared plus x can be is minus a quarter. And to achieve minus a quarter, you have to plug in minus a half. So, can I get more smiley faces, ladies and gentlemen? More smiley faces, please. So, yes, you can use calculus. Yes, you can use a formula for the turning point of a parabola, but you can also do this with completing the square. Alrighty, so now you ask yourself, so how is all of this helping? Alright, so let's start the problem now. So now back to the problem. We know that 1 is equal to 16 to the power x squared plus y plus 16x plus y squared. So this is what's given. So this is what's given. So it's given that this is true. All right. And now what I'm going to do is I'm going to apply theorem 1. So I am going to apply theorem 1, where a is 16 to the power x squared plus y and b is 16 to the power x plus y squared. Can I get a yes that you guys see? 1 is a plus b, a is this part and b is this part. Can I get a yes in the chat that you see my plan? Alright, so because of theorem 1, I know that a plus b is greater or equal to twice root ab. Are you guys there? Can somebody unmute and give me a yes? Thank you, everybody. All right. Good evening. No worries. Glad you've joined us. All right. So we know it's greater or equal to twice the square root of 16 to the power x squared plus y times 16 to the power x plus y squared. All right. And who can tell me what's the square root of 16? What's the square root of 16? Without a calculator? Yes. So it becomes 4 to the power x squared plus x plus y squared plus y. Alright? And can I get a yes that you guys now see why this work is useful? Because this is occurring there and this is occurring there. Alright? Can I get a yes in any language? Alright, if you can speak all 11 official languages of South Africa, that is great. So now you can see why my second observation is so useful. Alright, my second observation is quite useful because now we know that this is greater or equal to 2 times 4. The smallest that this can be is a quarter, and the smallest that this can be is a quarter. And so if we now do the maths, minus a quarter plus minus a quarter is minus a half. And what is 2 times 4 to the power minus a quarter? Without a calculator. What is 2 times 4 to the power minus a half? I'm sure you guys agree that this is 1 over 4 to the power of a half. I'm sure you guys agree this is 1 over the square root of 4. And what is the answer, Lindy, Chatterjee, Christian, Lindy? What is the numerical value? Yes? All right. So, do you guys all see that the answer is 1? All right. So don't let the symbols catch you out. So sometimes take it slow and steady wins the race. All right. And now we see that 1 equals this, which is greater or equal to this, it's greater or equal to this, and eventually equal to 1. So what we should have is that we must have equality. Can I get a smiley face that you guys see? Because 1 is equal, greater equal to that. In this case over here, this must be an equal sign and this must be an equal sign. Can I get smiley faces that you guys see that we got to have equality? And because we got to have equality, this now forces, all right, you can write a paragraph, you got to have equality, and this forces x squared plus x should be minus a quarter. So this forces x to be minus a half. And likewise, y squared plus y must be minus a quarter. So it forces y to be minus a half. So we see there's only one single pair. So there's only one pair where both x and y is minus a half. And so the answer to this question is B. So this odd looking problem, this interesting looking problem, this intriguing looking problem, the answer is B. Are there any questions or comments? You're welcome to unmute or let me know in the chat. So you can see it is an Olympiad problem, but you can solve this problem using elementary school results. And please be careful when you see square root signs and exponents. Rather take it slow and steady. You are welcome, Christian. All right, so remember, maths in some sense is like doing surgery. All right, although the consequences of making a mistake is not as serious as operating on a human, but still you want to avoid making mistakes. Are there any more questions or comments? I hope you enjoyed this example. So even though you have 2 unknowns and 1 equation, but when you do the mathematics, it turns out that x must be y must be minus a half. So x must be y, and both must be minus a half to solve this multiple choice question. Alrighty, you guys are very quiet. Maybe you guys had a long day. Alright, so before I go to problem 3, just want to remind you that you can download past South African papers and solutions from the SAMF website. Alright, and I believe the team's competition is 11th September. And guys, this is a very important tip. Doing Maths Olympiad problems are brain training for university. Alright, so please tell your teachers, tell your friends at school, those in grade 12, 11, 10, 9, and 8, that do take part in Olympiads. Don't worry so much about the scores, but it is important brain training for university. So a lot of lectures at university, we are not taking prisoners, all right? And sometimes we do put in challenging questions in a test and an exam. So you are the captain of your own learning. So you got to make sure that you understand the content that's being done in class. And at school, they pamper you maybe a little bit. Pampering doesn't happen at university. All right. If you don't put in the hours yourself over evenings, over weekends, then you are not going to appreciate the work that you're doing at university. All right. So my tip is aim to do at least one Olympiad problem per week. So you can obviously download problems from the SAMF website. And if you want to, you can even try to do a paper every week or every 2 weeks or once a month. All right. So let's start with this problem. So obviously this problem we want to solve without a calculator. We want to solve this problem without a calculator. So the cube root of this minus the cube root of this. All right. So just for fun, let's have a look at what's the inside. In this inside, we have this. And this inside, we have this. All right. So who can tell me what's the answer for this problem without a calculator? So no calculators, no cheating, no calculators. All right. It's again playing with square root signs. Who is fastest finger first? Who can do this calculation without a calculator? Yes, Robert. Gold star to Robert and a gold star to Chachaji. This is difference of squares. So it is this guy squared minus that guy squared, which becomes 25 times 2 minus 49. And the answer is 1. So thank you, Robert. Thank you, Chachaji. Thank you, Lindy. You guys are smart. The answer to this question is 1. All right. Now, this is an Olympiad problem. So you should be able to solve it without a calculator. All right. So looking at this question, we write down the following hope. We hope that 5 root 2 plus 7 is something cubed. Let's hope it's of the form a plus b cubed. All right. So because we're going to take the cube root of this number 5 times root 2 plus 7. All right. So we hope that it is something cubed. All right. Now, who can tell me how would you do a plus b cubed without multiplying a plus b with itself 3 times? Yes, if you feel energetic and you haven't had lots of classes at school, you haven't had exams to write today, and if you haven't had lots of sports activities, how can we work out a plus b cubed quite easily? All right. Yes, Lindy. All right. We use the binomial rule. Can I get a smiley face if you all know the binomial rule or Pascal's triangle? So give me a smiley face if you've heard of Pascal's triangle or you have heard of the binomial theorem. So you can see the next row, you have ones on the corners. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, you have 1. This is known as Pascal's triangle. All right, and if you 1, 2, 3, 4, only 4 people have heard of Pascal's triangle. Alex, Christian, Daniel, Duan, Edward, Gerdian, Jared, Kiahan, Laila, Lindy, Laurie, Luan, Richard, Robert, Sharik, Maharaj. If you've heard of Pascal's triangle, welcome. All right, good. All right. So looking at this, we can apply Pascal's triangle, and we know that a plus b cubed will be a cubed plus 3. So we go to this row. 3a squared b plus 3ab squared plus b cubed. Alrighty, so we are hoping that this is true. Alrighty, so we know that one of the terms should have a root 2 in it. Alright, so we know that possibly one of the terms should have a root 2 in it. Alright, so we scrap this plan. We now have a look at a plus b root 2 cubed. So if we apply this, this becomes a cubed plus 3a squared b root 2 plus 3ab root 2 squared plus b root 2 cubed. So if you rearrange this, and I'm going to collect this term and this term together, I get a cubed plus root 2 squared becomes 2. 3 times 2 is 6, so this becomes 6ab. And then the other 2, I can take out root 2 as a common factor, and I left with 3a squared b. And here I get b cubed. Root 2 times root 2 is 2, and I get this. Can I get a yes that you guys follow the maths? So the a plus b cube plan, we're going to modify it to a plus b root 2 cube plan. And so we end up with something that now looks like this. All right. And so now we say, okay, I am hoping that this guy is equal to 7. And I'm hoping that this guy is 5 root 2. So I want this guy to be 7. And I want this guy to be 5. So using inspection, what do you guys think will work for the one circle to be 7 and the other circle to be 5? It's quite clear. So using inspection, trying something, remember, it's good to try things. If it works, great. If it doesn't work, you go back to the drawing board and you try something else. Do you guys agree with Lindy? Yeah? Quite right. So A equal B equal to 1 is good. Alright? And so it's not hard to see that 5 root 2 plus 7 is equal to root 2 plus 1 cubed. Alright? I'm going to leave it for you to verify. And so therefore the cube root of 5 root 2 plus 7 is equal to root 2 plus 1. And in a similar way, you can see that 5 root 2 minus 7 is equal to root 2 minus 3 cubed. And so the cube root of 5 root 2 minus 7, that's equal to root 2 minus 1. And so the answer that we're looking for is this minus this. And who can tell me? So the one cube root becomes root 2 plus 1. The other cube root becomes root 2 minus 1. And if you do this mathematics, quite right, you get the famous problem 1 plus 1, which is equal to 2. Alrighty, so that is the answer to this question. There could be other ways to solve this question. Thank you, Lindy. Thank you, Christian. So the answer to this question is 2. Indeed. All right. Are there any questions or comments? Are there any questions or comments so far? So if you don't know the binomial theorem or Pascal's triangle, explore it. You can have a look at the Wikipedia page. But Pascal's triangle is very handy to help you to work out a plus b to the power 3 or a plus b to the power 4 or a plus b to the power 5 or any positive integer that your heart desire. Alright guys, you're welcome to shoot me a comment in the chat. I am looking at the chat. And so yeah, alrighty. So if there aren't any questions or comments, can I get a yes that you guys are ready for a geometry problem? Can I get a yes that you guys are ready for a geometry problem? Alright, so I have a no, I have a maybe, I have an ellipsis. We have a big fan of geometry. Thank you, Layla. Alright, so some people are more an algebra girl than some people. All right, let's have a look at this question. All right, so looking at this question, what sport does this question make you guys think of? Looking at this question, yeah, it's like pool or like a billiard table. All right, like pool or billiard table. All right, let's have a look at what the question is. The question was in last year's South African Teams Maths competition. It was in the Teams paper. So in the team's paper, you get 10 problems. Each problem is 100 points. And the question goes as follows. In this rectangle, 32 by 30, the dotted line segment bisects the obtuse angle through which it is drawn as shown. What is the length of this dotted line if the other line segments has sides as mentioned? So that's 30, that's 25, that's 7, and that's 24. Alrighty, so we need to solve this question. Alright, so a big tip when solving geometry questions is possibly redraw it and draw it as big as you can. Alright, draw it as big as you can so that you can do some calculations. Alright, so we know that that's 30 units. We know that that's 25 units. We know that's 7. So it's a rectangle. So what are the angles on the corners? Who can tell me what are the angles at the corners? Yep, they're all 90 degrees. So we know that that's 90 degrees. Alright. And so if we connect it over there, that's C, that's 24. And we know that those two angles are the same. Alrighty, who can give me a starting point? I have just sketched this whole diagram again. So who can give me something new? Alright, what about point P? Mr. Basson, give me something new. Whatever you say, I'm pretty sure it's going to be useful. Let's call that point B for fun. Let's call that point D for fun. Let's call that point E for fun. Let's call that point F for fun. If you have animals, you give them names. Alright, Lindy wants to connect A to C. Alright, let's hold on that for a moment. Alright, so Layla, why is PC 25? So why is PC 25 units? Who can give me the reason? Yes. I'm going to spell out Pythagoras. Alright. Lindy, are you happy? Angle D is 90 degrees because it's a rectangle. So PDC is a right angle triangle. So PC is 25. Can I get smiley faces that you guys see what we have now? We have that PC is 25. Alright. Now, before we do some other stuff, before we do a sneaky construction like we did with the first problem, who can tell me what's the distance from E to C? I'm sure some of you are doing accounting, and maybe some of you guys are planning to study actuarial science at UP. Yes. So in a rectangle, opposite sides have to add up. So F to B is 30, so E to C is 6. Alright, so that is 6. Alrighty. So we are making progress. We're getting to know the question. Alrighty. Now, we haven't used the fact that those two angles are equal. Who can give me what is the magic construction to solve this problem? So, pull out your Harry Potter wand. And what is the magic construction? Alright? Yes. I like Lindy's idea. Alright? So I like Lindy's idea. We're going to connect B to C. We're going to connect B to C. Alright? And where AB and BC intersect, let's call this point G. Alright? So, can anybody now give me an important observation? So the trick here is to connect point B to point C. So we have that line segment, and where that line segment intersects AP, we get point G. Alright. And so, yes, Richard, BP is PC, they're both 25, so that's quite suspicious, Richard. So capitalize on that. Look a little bit deeper, Richard. Any takers? Angles to equal sides, yes. Christian, you're getting warm. Richard is warm. Christian is warm. So why, Alex, is BG equal to GC? Please convince me, anybody. Why is BG equal to GC? I agree with that. But remember, you got to convince your teacher. And if you're matric and you're writing your matric paper, yes, a virtual chocolate to Richard and Christian. All right. So this is what I'm looking for. I would like you guys to say BP is equal to PC because they're both 25. You can say that GP is equal to GP because this is a common side. And we can say that BPG is equal to GPC because this is given. And so we now have that triangle BGP is congruent to triangle CGP. And what is the reason? What reason do you guys give at school for saying that triangle BGP and CGP are congruent triangles? Yes, side angle side. All right, side angle side. Do you see? It's an Olympiad problem, but you get to use your knowledge from school. All right. So yes, Lindy, you're quite right. So in English, it is side angle side. So Lindy, I will give you full marks if I'm marking your matric script at the end of the year, but I'm not marking matric scripts. All right. So no, that's fine, Lindy. That's fine. Afrikaans is also my mother tongue. All right. So now to take this further now, we know that these two triangles are congruent, so we can flap them onto one another. All right, so we know that BG is equal to GC. All right, but what is another important observation now? So knowing that these two triangles are congruent, who can give me, what can we extract from that? I know I am making you guys think. It's been a long day. I've had a long day as well. But looking at angles as a hint, what can we extract from the fact that these two triangles are congruent? Anybody? Yes, Robert, quite right. Because the triangles are congruent, we know that that angle and that angle has got to be the same. And so both of those angles are 90 degrees. Can I get a smiley face that you guys all see this? Because those triangles are congruent, those two angles are the same, and it has to add up to 180, so they both have to be 90 degrees. All right, so pretty cool so far. All right. Ooh. Remember, every time you have a triangle with a 90 degrees, we can apply which theorem? Every time you have a triangle, so yes, BG is also equal to GC because it's, yeah, thank you, Lindy. We can also apply Pythagoras. All right. So what side can we also work out using Pythagoras? Have a quick look at this diagram. What side can we also, yes, Mr. Talyard, quite right. You can also work out BC. All right. So I'm going to leave it for you to work out. Well, this one is actually not that bad. So this is 32. That's 90 degrees. That's 24. So can we work out this? Well, if we have triangle with sides 3, 4, what's got to be the last side? What's got to be the last side? If the triangle, a right angle triangle, yep, it's 5. Now, what do you do from 3 to turn it into 24? You multiply by 8. To go from 4 multiplied by 8, it's 32. So 5 times 8 is 40. Do you guys see? You don't need a calculator. If you take the triangle 3, 4, 5 and you make it 8 times bigger, you get the triangle with sides 24, 32, 40. And so, therefore, can I get a smiley face? This is quite clever. So, yes, you can do the maths if you want to, but if you take the 3, 4, 5 triangle and you scale it up, you get this. And so, we know that both of that is going to be 20. Alrighty. Now, let's return to the problem. We've been playing with the problem. We got to work out AP. We got to work out AP. Alright. So, anybody, any ideas how to work out AP? We've been playing with the problem. And any ideas how you would work out AP? There are two approaches here. One approach, you can use similar triangles, but I'm going to use trigonometry. So I'm going to call this angle alpha. All right? I'm going to call this angle alpha. All right? And so looking at this diagram, who can tell me if that's 20 and that's 25? We can work out GP. What's GP? Using Pythagoras. Again, take the 3, 4, 5 triangle and scale it up appropriately. Yes, 15. So you can spend another paragraph writing that out. All right, so I'm not writing this out because I want you to see the whole diagram. All right, so we know that tan alpha is defined as opposite over adjacent. So who can tell me what tan alpha is? Who can tell me what is tan alpha? What is tan alpha? Anybody? Look at this diagram. So everybody knows tan is opposite over alpha. So looking at this diagram, what is the numerical value for tan alpha? Any takers? Yes. All right. So I think Chachaji, you have it the other way around. So if you take this angle, this is the opposite, it's 20, and that is 15. So it's 20 over 15. Chachaji, do you see? Opposite angle alpha is 20. The adjacent to angle alpha is 15, so it's 20 over 15. Okay, good. All right. Yay, no worries, no worries. All right, it's been a long day. All right. Okay. So remember, one of the tricks in mathematics is to work out things in multiple ways. So one of the tricks in mathematics is to work out things in multiple ways. All right? Now, the tan approach is not actually quite helping. What I'm going to do is I'm rather going to do sine alpha. Who can tell me what is sine alpha in this diagram? What is sine alpha in this diagram? Any takers? So you know the formula for sine alpha? So sine alpha, yep. It's 20 over 25, which is 4 over 5. Good stuff, everybody that is saying 4 over 5 or 20 over 25. Now the reason why we do this is from point A, I drop a perpendicular. Let's call this point K. Can you guys see in triangle AKP that this angle is alpha and that sine alpha is defined as AK over AP? Can I get a smiley face that you guys see? In triangle AKP, an alternative for sine alpha is AK over AP. I want 3 more smiley faces. So this is sine alpha. Opposite alpha is AK. The hypotenuse is AP. Can I get yes? Thank you. All right. And now, which one do we know? Which one do we know? Do we know AP or do we know AK? And what is the one that we know? Who do we know? AK or AP? Yes. Remember, we're playing in a rectangle, so AK is 30. So what we end up getting is that 4 over 5 is 30 over AP. And if you do the maths, AP turns out to be 75 over 2, or it's 37.5. 37.5. Are there any questions or comments? So the answer to this question, sorry, I meant to say 75 over 2. 75 divided by 2, which is 37.5. What did you guys think of this geometry question? Lindy, Layla? I think it's a nice geometry question. All right. So maybe there are other ways of solving this question, but I agree with Richard. All right. So remember, in the teams competition, each problem is worth 100 points. All right. So maybe you can solve it in a quicker way, but this is the solution that I came up with. Indeed. So the nice thing about Olympiad problems is sometimes they're unseen problems, and just with a touch of creativity and a touch of playfulness, you can solve these Olympiad problems. All right. And the point of Olympiad problems is to challenge you. All right. It's to challenge you and to see very cool algebraic problems, very cool logic problems, very cool geometry problems, counting problems, number theory problems, inequality problems. As I said, it is endless fun that you can have with these kind of questions. All right. So to finish off the evening, I want to look at this geometry problem. So we played with a 3, 4, 5 triangle. So what I have here is I have 3, 4, this angle is 90 degrees, but then I split this using the angle bisector, and then I have two sides, x and y, and I want to work out what is x times y. Now, to solve this question, you can use the following theorem, and this is known as the angle bisector theorem. All right. To prove this, you just need trigonometry and the sine rule. The proof is actually very short. And I'm sure you can find it on the internet. If that's angle A, this is angle B, and this is angle C. And if D is on BC such that those angles are the same, so that angle BAD is the same as angle DAC, then the angle bisector theorem says that AB over BD is equal to AC over CD. So that over that is equal to that over that. Can I get a smiley face if you have encountered the angle bisector theorem, maybe when you were doing some Olympiad problems over the weekend, or maybe training for the South African round 2 or South African round 3, or you've been doing some extra Olympiad problems just for fun, doing some brain training to get yourself ready for university, if you're going to study engineering, if you're going to study actuarial science, or anything in science. All right, there's a couple of people that have seen this result. All right, so that is actually very good news. So coming back to this problem, if this is 90 degrees, that's 3 and 4. So we know that x plus y is equal to 5. And the reason is what, ladies and gentlemen? Why is x plus y equal to 5? Any takers? Yes. So using Pythagoras, since, and let's actually be a little bit more specific, since angle ACB is equal to 90 degrees. I think in my matric exam, I got full marks for the algebra paper, but I lost 2 marks in the geometry paper because in one question I forgot to add a reason. So I think I ended up with 99% for matric mathematics. So please, if you are matric right now, And especially with geometry questions, remember to add your reasons. So say the triangles are congruent because of side angle side. Remember to say I'm using Pythagoras in triangle ABC because angle ACB is 90 degrees. All right, so some of the markers, they just want to mark 1,000 scripts a day. So sometimes they don't even look at what you write down. So if they're looking for a reason and there's no reason and the marking memo says you got to have a reason and they don't see a reason, sorry, you're losing out on the mark. So this is what happened to me. Alrighty. So now if we look at this, this means that y is got to equal to 5 minus x. And so we can now apply the angle bisector theorem. So we know that because these two angles are the same, we know that 4 over x is equal to 3 over y. And we know that y is 5 minus x. Can I get a smiley face? Or if you have a question, you're welcome to ask. So I am sure the angle bisector theorem has a Wikipedia page. I haven't explored Wikipedia in a while. And so how do we solve this? This is a primary school problem. You cross multiply. So you get 3x is 20 minus 4x. So you get 7x is 20. So x is 20 over 7. So x is 20 over 7. Who can tell me what is y? What is y? So y is what over 7? Any takers? Yes, Ms. Chatterjee, good stuff. All right. Your arithmetic is really good. And so we can now finish this question and we can say xy is 20 times 5. Do you guys agree it's 300 over 49? Can I get some yeses that you guys agree with my mathematics? I've also had a long day. I have 1 yes, 2 yes. Can I get a third yes? Yep. Thank you. All right. It is good. Thank you, Jared. I appreciate the yeses. All right. Always double check your lecturer. You know, they could have a blunt moment or two. So the answer is indeed 300 over 49. And that is the answer. So, and that is my story for the evening. So thank you very much for attending. I hope you've learned something. And remember, please use Google, download some Olympiad problems. Go to the SAMF website, download some Olympiad problems, and have some adventures on your own. I want to finish off by saying, if you are matric, good luck with your exams, and I hope you're coming to UP to study something really cool. If not, I will have again classes in 2020, and we will have some more fun with Olympiad.